This talk is about D3.js, which I'm guessing most of you at least have an inkling that that's a data visualization, something or other to do with JavaScript. I think the first thing I'd like to do, though, is sort of clear up a misconception that I know a lot of people have. Certainly I had 3 or 4 years ago when I started playing around with D3. D3 is not a charting library. And what I mean by a charting library is this example code here. This happens to be from a charting library called HiCharts. There are half a dozen other really good charting libraries available in JavaScript. This is just one of the more popular ones. Actually, I grabbed this from the HiCharts webpage on their demos, and this is the very first demo they present on their webpage. I've never actually used HiCharts in a project, by the way. I just grabbed it and looked at it. But it's about a dozen lines, but it's just one JavaScript statement. That's all that's there. And with that one statement, you get a chart. That's what I mean by a charting library, is that you have a JavaScript library that has an API, and you feed that API data, and magically a chart appears on your web page. That's not D3. So how does D3 compare to a traditional charting library? Well, the way I like to think about it is a traditional charting library is kind of like buying a home the way most of us would buy a house, right? We go find a real estate agent. The real estate agent takes us to a few homes in the neighborhoods that we are interested in, shows us a few models. We say, yeah, I kind of like that one. We pick it, we move in, we can change the carpet, we can repaint the walls, but we pretty much are shown a model, we get the model, and that's our house. Well, if that's a traditional charting library, then buying a home with D3 is like buying a home at Home Depot. And if you think about it, provided that you own property, you can buy a home at Home Depot, right? They've got lumber for framing, they've got stucco for the exterior, they've got appliances, they've got plumbing, they've got wiring, and you're going to need some tools to assemble this home that you're buying at Home Depot. And yes, Home Depot has the tools for you. You're probably going to need all this material delivered. You can rent a truck at Home Depot. To me, that's a lot like building a chart with D3. Now, that seems like a lot of work, and as we'll see, it can be a lot of work. But the benefit is you get to build exactly the home you want, or exactly the chart you want. You're not restricted to the canned options in the charting library, just like you're not restricted to the examples that your real estate agent shows you. You can build anything you want. I mean, we'll ignore zoning laws for the moment. So if D3 isn't a charting library, I think one of the things that's important to understand is what is it? And what I like to think, well, to be honest, the name kind of gives it away, right? D3, it's an acronym. It stands for Data-Driven Documents. And the main purpose and the main philosophy behind D3 is it associates data of whatever kind that you have with elements in your DOM, in your document object model, and it gives you the tools to manage the results of that association. So it's really about tying data to elements in the DOM, and it provides a whole slew of tools and utilities that will help you do that association and create visualizations from it. If you look at the D3 website, right on the front or the second page or whatever, it lists the main components. So I'll just kind of give you the rundown of what Mike Bostic says D3 is. And he will say it's a library and you're free to use it with other stuff. I think the philosophy is a little bit stronger than that. I think, to my mind, D3 is everything you need to create visualizations or other data-driven stuff in a web browser. It's not just a library that you use along with other stuff. And for the most part, if you find that you're using a lot of other stuff with D3, then you've probably got some redundant things going on, perhaps. For example, one of the first things that D3 has, it has what is called the core. The D3 core, it has a lot of utilities for managing selections, transitions, getting data, colors, localization. And if you're familiar with something like jQuery, you might say, hey, jQuery does quite a lot of those same things, and you'd be right. So in many ways, D3's core is very similar to a lot of the core stuff in jQuery, except it's focused more on data visualizations and data manipulation. There's very rarely a reason that you would need D3 and jQuery on the same web page. There's only a small fraction of things that jQuery does that D3 won't do for you, and they're probably not worth the entire jQuery library. Another major chunk of the code in D3 are what D3 calls scales. And a scale is just an abstract utility that converts between data and all different types of visual encodings. And a visual encoding can mean the position on a page, the XY coordinates in an SVG tag. It can mean the color, that's another visual encoding. Things like that, D3 has tons of utilities to manage. Most graphs, though you don't have to use SVG with D3, but most graphs or visualizations that you create with D3 are likely to use SVG. And recognizing that, D3 has a lot of utilities that make working with SVG a lot easier than manipulating the raw DOM elements. A lot of data visualization involves time series data, timelines and such. So D3 has a pretty rich set of utilities for dealing with times. Some of your visualizations are a little more sophisticated than simple line charts. If you've looked at D3 examples, you'll see elements on the page that are molded together in very complex ways. D3 has a concept called layouts that are tools that will help calculate all the positioning information for those elements for you, so you don't have to mess with the math. I mean, if you are scared of trigonometry, don't worry, D3's got you covered. You don't have to do any trigonometry. D3 will handle all that for you. A lot of visualizations involve maps, of course, and D3 has a very extensive set of utilities for dealing with geographic data. A lot of projections. I barely remember from like elementary school, was it? Like things like the Mercator projection and stuff. D3's got you covered. It also can do latitude and longitude math, can do polar and spherical coordinates, that kind of stuff. D3 has other utilities for dealing with more special purpose 2D geometries like Voronoi. I'll actually show you an example of that. If you don't know what it is, you'll see the example and it'll probably be like, oh, that's cool. And finally, since this is a web page, D3 is designed for web pages. Web pages can be interactive, and so D3 has a lot of utilities for managing interaction behaviors, things like panning and zooming, clicking and things. Again, those are things that you might expect or you might be used to using from jQuery. D3 has all the same functionality that jQuery does for event handling. So I think maybe the easiest way to kind of see how that philosophy works in practice is to actually build a chart. I won't go into a lot of details, and this is probably a good place where I'll skip some of the really technical stuff to keep my brain from overflowing. But I will kind of walk you through the highlights to building a chart with D3. And we'll use a simple line chart, so there are really only 3 steps. One is we're going to set up the scaffolding for the web page. Then we're going to rely heavily on D3 scales to map data to the DOM elements. And finally, we're going to actually draw the chart itself with SVG. So in fact, not to keep you in suspense, but the chart that we'll create is exactly that high charts graph that I showed at the very beginning of the presentation. We'll just do that in D3 instead of high charts. So the scaffolding, nothing surprising there, just standard HTML5. Include the D3 library, of course. D3 can handle data in all kinds of formats, tab separated values, comma separated values, raw text, XML, whatever. JSON's obviously the easiest to work with in JavaScript. So we'll assume that our data is available in a JSON format. This is actually the data that I reverse engineered this from the high charts demo. And now when we start up our JavaScript code, one of the first things we're going to want to do is retrieve that data. And obviously with that small bit of data, we could just embed it in the HTML. But if you're doing a more sophisticated visualization, you may have the data in a separate file. So D3 has utilities to do Ajax requests for files. So line 1 here is an example of that, where we're doing D3 a request for JSON. This is exactly like jQuery's $Ajax or $getJSON. So we get the data. As you saw from the data, there were, I'll go back to it. There are actually 4 data sets, one for each of the 4 cities. So we'll iterate through there, and as we iterate through the data sets, notice that we are converting what is in the data set. I'll go back to it as just an index in the array. We're going to convert that to a time. And that, again, I list that as an example. It's line 5 and 6 there, just to show you that D3 has utilities to manage times. In this case, we're creating months out of just an index into the data. Now, once we've got our data, we want to define some scales that we talked about. And these scales will be what we use to map the data to our DOM. And this first set of code here is how we could create a scale for the Y data, the vertical axis data, or Y data here. And we're using a linear scale. We're not doing anything fancy with logs or any stuff like that. And when we create a scale in D3, we tell it the range, and that's where it's going to appear on the page, and the domain, which is the values that are in the data set. And there's an interesting twist there. If you notice that range, it's going from height to 0, and which is backwards from what you might expect. But that's just because in SVG, the 0 Y position is the top of the SVG container, and it grows down the page, just like CSS does. So in order to account for that, we've swapped the position. So that's kind of all it takes to create our first scale in D3. And you notice we're using this little utility called extent. And that extent will search through all our data and find the minimum and maximum values. So we don't have to do that by hand. And then the nice utility takes our scale and kind of makes it nice rounded numbers instead of a scale going from 1.375 to 20.438. It'll round them off to nice human readable numbers. That was a linear scale. Scales don't have to be linear. I mean, you can obviously think of logarithmic. Here's an example for the x-axis where we're graphing the temperature by months. That's a time value. And again, D3 handles time values just perfectly. Again, even the D3 extent function can deal with time values. And a little trick here, since our data is theoretically starting on January 1st, we actually want to shift the chart so that that doesn't show up right on the y-axis, but move it over. That's why we extended the scale a little bit. So now we've got our scales. We're ready to start mapping the data. This, again, probably looks a little bit like jQuery for those of you that are familiar with it. We're going to select the body of our HTML document and append an SVG element, and then set that SVG element's attributes, its width and its height. And just a note there that probably everybody that comes from jQuery learns with D3 is the append function in D3 returns the newly appended selection, which is different from jQuery, in which the append function returns the original parent selection. That will cause you grief until you finally realize, oh, that's what's going on. And with that, we're actually ready to graph the data points. So this is the traditional way you would graph those data points in D3. And I want to focus just on the first 3 lines because those are really kind of weird. They certainly seem weird until you get used to D3's nomenclature. The first thing you're doing is we've got that SVG, which we created, and now we're selecting everything which has the class point in line 1, and we're associating data with that selection in line 2. And then in line 3, we start creating SVG elements. But what's interesting about that is so far we don't have anything in that SVG container, right? All we've done is put an empty SVG container on the web page. So you would think that when we call select all, looking for anything with a class of point, that there's going to be nothing there. And that's actually right. The very first time we execute that statement, in fact, the only time we execute that statement in this code, the result will be an empty selection. But D3 is really cool about handling empty selections. Even though there's no DOM element in that selection, D3 will manage it as if there might be some DOM element in the future, and it will associate data with that potential future DOM element. So a way you can sort of think about it visually is if we've got a set of data, and that's on the bottom of this slide, we've got temperature data, 7 degrees, 6.9 degrees, 9.5 degrees. What we want to do is associate each of those data values with an SVG path element. And that path element, actually we probably want to make it a circle element in this case, we'll create a circle element. Well, if we had 3 path elements already in the DOM and we had 3 data values, then it would make perfect sense that D3 would marry 1 DOM element to 1 data value. Well, what happens if we only have 1 DOM element in there? Well, D3 will still keep track of the fact that there are 3 data values in there. It's just that the second 2 don't yet have any DOM element associated with them. Same thing works if there's 0. And with that, we can sort of look at line 3 here. And line 3 starts to fill in the missing DOM elements. And the key is that very first function called enter. And D3 views a visualization as like a stage where actors enter the stage and exit the stage. And actors in this case are DOM elements that are getting data for the first time, and exiting actors or DOM elements that have their data removed. So when we call enter, D3 is going to create a set of it's going to find the elements of data in our data set that don't yet have a DOM element associated with them. And then the next statement, append path, they're going to append a path to that empty selection, which will stick it in the DOM. So that line 3 is creating a new DOM element for all of the data elements that didn't have a DOM element existing beforehand. Now that's kind of a weird construction when you're just doing a static graph, and it's probably overkill for a static graph, but imagine that you're animating a graph and you have data that's constantly being updated. So you've got new data values coming in and old data values going away. In that case, you're frequently going to have new data values that don't yet have a DOM element. And with D3, you can easily identify those data values and create a DOM element for them. Now, once we've in line 3 here, once we've created that DOM element, then there's just standard styling stuff. We give it a class of point, because that's the class that we're using, and then various other things like fill and stroke, and the D element, the path that we're using for this element is a symbol. So D3 has a built-in library for doing standard plot symbols like triangles and pluses and dots and stuff. So that gets us the plots from our graph, and you may remember we also had lines that connected each plot for each of the cities. Adding the lines is pretty much the same thing. I won't go into a lot of details here. Again, we're going to look for paths for each data value, and we're going to set the fill and the stroke and such. It is worth noting that lines 7, 8, and 9 here, this is one of those D3 utilities that's really handy. It creates an SVG line for us out of the data. We don't have to worry about figuring out what the coordinates are, how to do curves and stuff like that. We just say, hey, D3, here's my data. You figure out how to draw the line. And then lastly, we do want to put some axes on our chart. So here's how we would do that. And you'll notice that on line 3 and 4, D3 has a handy utility called axis that does all the dirty work for creating the axes and the tick marks and putting the values and all that stuff. We just have to call it. And that is the result of the code that we just created. That's the D3 version of the high charts graph. It's not exactly the same, but it's pretty darn close. Well, what's the downside of that? That was a lot of code, right? In high charts, it was one JavaScript statement. And how much code was it in D3? Well, let me scroll down. Now, admittedly, there's a lot of commentary in this code, but still, it is, we'll get to the bottom eventually, 280 lines of JavaScript to create that same chart. So I guess one thing you can take away from this, if all you need to do is create a simple chart, D3 is probably not, or maybe not, the best choice for you here. If you're happy with what the real estate agent shows you for homes, then by all means, like I said, there are plenty of really good JavaScript charting libraries out there. But with D3, we can do more. Now, one of the things, I look at that chart, and this was the default from high charts. I'm like, that's a really ugly chart. So the first thing I said was, what in the world are those ugly symbols there? So let's get rid of the symbols. And of course, with D3, we don't have to draw the symbols. I mean, you saw the code where it said put the symbols there. We can just omit that code. And oh, by the way, the animation on that previous slide, that was D3 doing the animation. This is a web page, by the way, this presentation. That's the entire code for that animation. So you think animations are hard? Well, with D3, it actually isn't. We selected all the points. We decided that we're going to animate them for 2 seconds, and we're going to bounce them. And the result of that transition is going to be we're going to translate them, we're going to move them to the bottom of the page, and then the last line there says, and by the way, once the animation is done, just delete these balls, symbols, whatever, off the chart completely. So that gives us this, which I think is mildly better, but all those straight line segments sure look ugly, right? So let's smooth the chart out by interpolating. And how do we do that in D3? It's one line. It's line 8. I'm using a B-spline interpolation in that example, but if you don't like that, if you want cardinal splines, cubics, linear, any other kind of interpolation, D3's got you covered there as well. So D3 can handle that. And then I was starting to think, why are we even bothering with this monthly values anyway? I mean, isn't that rinky-dink? If you go to the NOAA.gov website, right, you can get temperature data for any city for every day of the year. So I said, well, heck, we're in Atlanta, so let me just go get the average temperature for every day. And it's no harder to create this chart than it was to create the other chart. In fact, it's easier because I'm only doing one series here. And while I was looking at the data to do this chart, I said, there's another interesting thing that's built into the data from the NOAA.gov website. They also, not only did they have the average for each day, they have the standard deviation for each day. And I thought, well, that's interesting. Maybe we can chart the standard deviation. That's easy enough to do with D3 as well. To me, it was actually interesting. And now that I think about it, it's obvious, but notice how much larger the standard deviation is in the winter in Atlanta compared to summer. But that's still an ugly chart, right? It almost looks like a river, right, running through there. But I said, what we really need to do is add some gradients. Now, at this point, I have to stop because prior to this particular example, the stuff that I've done, I'm sure you can do in high charts and other JavaScript libraries. I said I've never used them, but I bet there's an option in their API that says don't draw symbols. And I bet there's an option in their API that says interpolate the lines. And there might be some option that you can do some kind of area chart to graph the standard deviation as a fixed area. But I haven't looked, so I could be proven wrong. But I bet there is no way that the standard charting library can do the standard deviation gradients like this. And if you think about it, it's really tricky because there's a separate gradient for every point. Because the center of the gradient is the average value, so you've got to change the gradient at every point. Maybe you can do that with high charts, or JQplot, or Flotter, but I'm dubious. With D3, it's actually pretty easy, and I'm not going to actually show you the code. It would explode my brain, but I will give you a link where you can see the code that does this, and it's actually not that hard. While I was looking at the NOAA.gov website, though, I looked around, and there's a bunch of other interesting data that's there on the website as well. One of the things they have is they have a database of every severe weather event reported in the country since like 1950 something. So I said, hey, that's kind of cool. Let me grab the data for like 2013. And I filtered it out and just looked for tornado sightings. And so why don't we put that on a map? Since they give you GPS coordinates and they give you the EF rating, the strength of the tornado. So this is a D3 map that you can create, again, very easily with D3. And D3 will handle all the GPS data. It will translate from GPS coordinates directly to your map projection. It's got a bunch of map projections. This is actually an interesting map projection. It's one created just for the United States, in that it moves Alaska and Hawaii down so where you can put them on a nice rectangular map. It's called an Albers projection modified for the USA. And D3 will handle, so if you got a GPS coordinate for a tornado in Alaska, which there weren't any, D3 would actually put it right where Alaska is on the map. Now this is a little bit different than a mapping library like Google Maps or Leaflet or something like that. Those maps are, now they're getting to be vector-based, but they tend to be tiles, whether they're vector tiles or image tiles. So the idea is you sort of layer tiles on there. With D3, they're not tiles at all. All of the map information is SVG vector elements. And there are tools that you can take standard GIS information and create what are called GeoJSON data structures that represent the geographic data. And D3 can take that GeoJSON and throw it on a web page and make it look like what the thing actually looks like. Now, one of the nice things you have when you have vector-based maps is you've got really good scalability. You don't have to worry about zooming in and your images looking blurry. And we can take advantage of that, as well as D3's interaction handling, and set it up so that if you click on any state, D3 will zoom to that state, and in this case, color it. And if you look at the map, afterwards you can go play with this map. You can zoom around to any state and such. And D3 has all the interactions necessary not only to zoom it and center the new state without you doing any calculations, but it will, as you can see here, it's set up so the dots representing the tornadoes don't end up being as giant as the state. So all of that works. The zooming, as you can see, was a nice smooth animation. It didn't just jump. Again, D3 can do that kind of stuff for you. And I mentioned Voronoi. Well, here's another little twist. I just couldn't resist playing with this. A Voronoi geometry, what it does is it's drawing boundaries so that anywhere within that boundary, the particular tornado sighting is the closest to any place in that boundary. It's kind of complicated, but obviously if you find where you are, and we're kind of, see, will my mouse show up? Yeah, we're kind of up in here. So whatever tornado sighting that one was, that was the closest one to where we are in 2013. And D3's got lots of utilities for doing fancy geometric stuff like Voronoi diagrams. But as I was looking at this tornado data, I kind of thought, well, okay, that's interesting, that's nice, but that's still a pretty traditional approach to showing tornado data. Can we do something a little more, I don't know, tornado-y with the data? And so I came up with this as a different way to visualize the tornado sightings from 2013. And this is an example of the layouts that I mentioned earlier, where D3 has these utilities that'll behind the scenes do all the nasty trigonometric calculations, trig in this case, because this is obviously radial, but whatever calculations you need to figure out where to map the data. So what this is, I'll hover my mouse over here. You can see in the US 2013, there were a little over 1,000 total tornado sightings. And then the next ring out are regions. There's the southeast and the plains. It's actually the southeast has more tornadoes than the plains. And then the next ring out is states. So Tennessee, see if I can find Georgia somewhere around here. There's Georgia. And actually we can click on that. And I said it had to be tornado-y, right? So now we've zoomed in on Georgia, and you can look at the individual counties. And it's not real exciting because there weren't that many, but I can tell you that Cobb County, where we are, is over there. So there was one tornado sighting in Cobb County, and this works. You can zoom back out. Do things like that with D3 and layouts. And just to give you a sort of a sense of this, that first chart that we did, the high charts demo that was 280 lines of code, heavily commented, but still a lot of code. Well, the example I did here, just as heavily commented, is less than 200 lines of code. So it's actually easier in D3 to create this than it was to create that dumb little average temperature in 4 cities chart. So I promised you I'd skip over the hard stuff, so it does mean we finished up a little early. But I do want to give you some extra resources. One is my personal website, which is jsdataviz, or if you like, it's jsdataviz.com, but that's not the real site. That'll just redirect you. What resources are there? One of the resources that's there is the full contents of the book I have, Data Visualization with JavaScript. That's all. Full contents are there online for free. There are lots of annotated and commented examples, including all the examples that I did in this chart, or in this presentation. So if you want to, at your leisure, go look at the examples that are there. In fact, the recent ones, as I mentioned, you'll see some stuff on mathematical modeling of HIV because I've been playing around with that lately. There are also all my presentations, including this one. So if you want to relive this presentation, it's there, linked to that site. If you prefer paper or ebook stuff instead of reading things online, there is a link to No Starch Press for the book. And I'm going to, well, it's on the slide, so I can't help but talk about it. But there might still be a coupon code pre-order, which will get you a 30% discount. And the reason I say might still be is as of this morning, it was still there because the book wasn't released. But the book is officially going to be released like maybe by now, maybe tomorrow. I'm not exactly sure when. So if you want to take advantage of that coupon code for pre-order, I think it's still valid, but it's likely not to be valid maybe even as soon as tomorrow. So those of you that don't want to take advantage of the pre-order, I do have, literally this is like hot off the press because I don't even have my author's copies yet. I can't, these aren't for me. They actually FedEx copies to me so that I could give them away at the presentation. So I have 2 copies of the book for those people that would like some. Well, I'm not going to walk out there and give it to you. Yeah. All right. See, now those people that sit in the back, even though I told you probably didn't want to sit in the back, now you know why. So I'll be happy, like I said, I finished up a little earlier. If you have questions, I'll be happy to take questions. And those of you that don't want to stick around for questions, of course, you're free to go. Yes?
I know this probably has a lot to do with the human's efficiency, but is there like a limitation on how much data you take in, or beyond, not going beyond what JavaScript?
The question for those that didn't hear it are there limits to how much data that D3 can deal with? And I've actually been pleasantly surprised that I have yet to find them. And I'm really shocked by that. And I think what I attribute that to is that D3 sort of relies on the DOM for doing a lot of the management. And we've heard things like with React that the DOM is terribly inefficient. Well, that's not really true. The browser vendors have been danged good at optimizing the DOM. What's not so optimum is repainting based on the DOM, but actually managing the DOM, browser vendors do very efficiently at that. And I mean, to give you an example, I have done visualizations in D3 of real-time time series data where it's animating in real time, or I have literally put 250,000 data points into the data set and filtered based on that. So obviously, you don't have that many pixels, so I'm not showing 250,000 data points, but I've got 250,000 data elements in D3, and then I'm filtering based on what the user selects. I want to see this type of data or that type of data, and D3 was able to handle that with no noticeable lag at all. So I have not run into. Now I'm sure there must be, and obviously if you're trying to show something on like an Android, Jelly Bean smartphone, then you're probably going to kill it really quickly with 250,000 data points. But on desktop browsers, it works really well. Question here?
Yeah. What are the compatibilities with the browser?
The question was, what are the compatibilities with the browsers? D3, in theory, works with IE8, but one of the things you'll find is IE8 does not support SVG. It does support a Microsoft proprietary thing called Vector Markup Language, VML. And there is a polyfill that will take SVG and convert it to VML, but the performance really, really sucks. So if you're doing really tiny charts without animation, then you can get away with IE8. But if you're doing anything realistic, you're probably doing it in SVG, which would limit you to IE9 and above. Other browsers, no problem. The mobile browsers, there's not a compatibility problem, but there tends to be a performance problem, especially on the lower-end Android devices. iPhones and iPads work well with D3. You had a question?
So you sort of piggybacking on his question, you were talking about the data that sort of held in memory for D3, but what are like the limits that you've seen with actually, the number of objects that you're sort of interacting with? We do a lot of like network visualization. You might have thousands of nodes and lines connecting them.
So the question there was, what are the limits, not so much on the data that you're dealing with, but on the ability to manipulate objects in the DOM. And I don't have a great deal of experience with that. I have done some work where there was an objective to display like network graphs, connected network graphs with thousands of nodes. And what I found, number one, the performance was sketchy, but more so than that, it was really hard to present that much information in a meaningful way to a user. It just ended up being a kind of a spaghetti mess of nodes with lines going all over the screen. So we ended up doing I ended up doing a completely different visualization for that. But yeah, hundreds of nodes, especially if you're animating them with drag and drop, which is what we were doing in that case. It's not really a D3 limitation, it's more a browser limitation there. And I would try to stay away from that. I think the rule of thumb I use, though, is what makes sense from presenting it visually. And if it makes sense visually, if it's not a forest of stuff, then I haven't run across any problems with performance.
How well suited is D3 to, let's say, subscribing to a stream of real-time data, like let's say location data for multiple points, and then displaying them on a map?
So the question is, how suitable is D3 for grabbing real-time data, such as points, and displaying them on a map? And D3 is super at grabbing real-time data. The whole paradigm, we sort of touched on it with this enter and exit thing. The philosophy, D3 is built from the very beginning to deal with real-time data, with data that's changing. So I have not found any performance penalty at all for dealing with real-time data. I haven't looked into it enough to know, like how good is its garbage collection, but I haven't seen any problems with it with huge amounts of real-time data. So maybe I'm just lucky, but I haven't felt the need to look into things like garbage collection. Any other questions? Yeah, sure.
So what about if, so I get the whole, geo and showing out a map. What if you wanted to, let's say, do an indoor and, render a space, somehow on the page and then have things be displayed on map, like an indoor map, or some arbitrary, map that you want to create?
That I have seen examples where people have created synthetic maps using GeoJSON, and I don't know. I've never used them, so I don't have any first-hand experience. But at least people have asked that question. Indoor data, it seems, unless if it's rectangular, then it would seem, linear scales would be perfect for it, where, your data would be some dimension like inches or feet or such, and that would easily map on a linear scale to a position on a floor plan, for example. Yes?
Is there any extra consideration when you're using D3 on the tablet or cell phone as a device?
So I think the question was, are there any issues with using D3 on a tablet or cell phone? Was that the question? The only issues I know about are really two. One of them is if you have really complex visualizations, SVG performance is not so hot on low-end Android devices. So if you've got to support low-end Android, then you may have a problem with performance if your visualizations are complex. And I also, in fact, now that I think about it, I think Android, I want to say prior to KitKat, but I'm not, don't quote me on that. You can have to look it up. But prior to KitKat, I'm not sure Android supported SVG at all. So that's one issue. The second issue is it can be a little challenging to deal with SVG responsively. It doesn't have to be. And the reason I say that is SVG, of course, is vector. So it scales. And you can use what's known as a view box to define the virtual dimensions of your SVG element and then scale that arbitrarily. So you could do that to shrink a graph down to the size of a smartphone. But except in the really simple cases, that tends not to be super satisfactory, because what you end up with is type that's like 2 points high by the time you take a nice desktop size visualization and just shrink it. So even though SVG has facilities for shrinking things or scaling things, you have to be a little careful about how you use them. You probably don't want to just put a blanket, scale this graph down to a smartphone, because your text will be a little bit illegible. And if you do the reverse, of course, if you start with a mobile first design and then scale it up, then your text looks big, and also the browsers, when they scale it, sometimes they pixelate when scaling up, even though it's vector-based. And I think by now all the major browsers have fixed that, but I haven't checked that in a while. So doing responsive visualizations is a little tricky. It's not quite as simple as you might hope. So those are the two issues that I know of. Tablets, D3 works great on tablets. I've done lots of tablet stuff. It's really the very small screens that I've run into problems. Other questions? Well, thanks everyone for coming. And I will also note that at the closing ceremonies, they do have 2 other copies of the book that they're going to raffle off. So if you missed out in this session, maybe you could get lucky over in the closing ceremonies. Thanks again.